Hello again, week 3, part 2. Welcome back. I'm glad you're sticking with us, and I hope you're finding the material through this course intellectually stimulating and engaging, but also practical in terms of you thinking about your own future teaching practice. In this course, we're not trying to make you all teach mathematics the same. We want you to try and think about all these things deeply, consider the students that might be before you, and decide how you're going to teach them as you go along. And as you go throughout your career, I hope you always change and develop. One of the things about being a teacher is you should be passionate about learning. And that means you as a teacher will want to keep learning about your teaching craft as you go along. And this week we're looking at ways you can manage interventions with kids and how you can help work through their errors and they're analysing them to plan your teaching. So here's the things we're going to cover. We'll spend quite a bit of time on Newman's error analysis, and this is a really practical and useful way to try and understand students' errors and misconceptions so you can help them develop. So one of the things we know is that kids in class will make mistakes. And then it's not like they're trying to deliberately get things wrong, it's just based on all the experiences we've presented them with in the class, they have then drawn some conclusions and learn some things, and those things aren't always the things we intended. So then it's our job as teachers to try and understand how they've come to that position and then see if we can go back and help them fix it. So, finding out why children make mistakes. Again, this is a video here to what we call Newman's error analysis. And this was developed by an Australian educator. And it was when someone tried to answer a problem, and it wasn't necessarily a mathematics problem, but it works really well with mathematics. It was trying to see the phases they went through to getting to the answer. They were sort of like seen as a series of hurdles. And although we know that any learning is complex and not quite as simple as just following like a hurdle race, this does seem to be a useful tool. So particularly when students get word problems, and things like word problems are things that kids will face, of course, in NAPLAN and in a lot of our activities we give them. So the first thing we always ask them to do is, can you read it? Do you understand it? Can you transform it into a maths problem? Do you have the math skills to solve it? And then can you turn it back into an answer that makes sense relative to the initial question? So we're going to go through this in quite a bit of detail in this video, and we'll hopefully have some resources here that you can follow up and see, like the link at the top here, because we think it's a really good and practical thing to do in your classroom with the kids. So what does it look like? Well, Newman's error analysis has these 5 stages, and it's got these 5 questions or prompts that you would ask the students. And this is going to come up a few times in this lecture just to reinforce it. And also I'll probably try and get a copy of it and put it as just a Word document for you in the site so you can use it without having to try and copy it from here. Personally, I used to have these questions up on the posters around the classroom. And what would happen is a kid in the class would put their hand up and they might be stuck for some reason or another, and they knew the first thing I would ask them is, can you read me the question? The reason you ask them, can you read me the question, is to see if they actually have read it and make sense. The second thing I would ask them is, what's the question asking you to find out? And again, I would point them to the poster on the wall where these things were written. The third thing, what method or what mathematics could you use to get to the answer? And that was about transforming it from a word problem to a mathematics problem. And the fourth one is, okay, you try and do it, and while you're doing it, tell me what you're thinking as you're solving it. And that way I was seeing how they were processing it. And then the last thing I'd say is, can you write down your answer to the original question? And that was seeing if they could then encode it back to the original response. The kids in my class got so sick of it that they'd put their hand up and they'd start off saying, oh, excuse me, sir, can you do? And I'd go, no, read me the question. And after a few weeks, I'd come over, they'd put their hand over, I'd come over, and they'd just start reading me the question. They knew what the response was going to be. It's a really powerful way, and it's been used in lots of primary and secondary settings, particularly for word problems in mathematics, where it's been powerful. I'll give you an example. This was taken from, in New South Wales, they used to have a test called SNAP, which was a forerunner to NAPLAN. And here's a question that appeared one year. Natalie paddled 402 kilometres of the Murray River in her canoe over 6 days. She paddled the same distance each day. How far did Natalie paddle each day? So with this question here, again, I've given it to many students, and I'll come over. The first thing I'll say to them, can you read me the question? And what you'll find is at this point, you'll solve about 60% of the problems because they don't read the question. Commonly they'll say, Natalie paddled 402 kilometres over 6 days. How far did she travel? And then from that, if you don't ask them at this point, if you just let them go, the most common answer was 402 times 6, with the answer of 2,430 something. That's terrible, isn't it? So the first thing I'd say to the kids, can you read it to me? And I found out that most of them didn't read the question correctly. About 50 to 60% of the kids couldn't read the question. Other things they got stuck with, where it says each day, they didn't read that part commonly. Some of them didn't understand a Murray River, what the river was, that confused them. We found this often, a lot of word problems try and use names from different cultures, and sometimes kids from different cultures didn't understand what the name meant. Anyway, the first thing to do was to ask the kids to read it, and that solved about 50% of our problems. The second is, what is the question asking you to find out? And the kids would say, how far she paddled. So again, this told you that they weren't able to make sense of the question. They didn't know what the required part was. And see, the answer isn't asking them how far, it was how far she travelled each day. So again, at this point, we've solved about another 15 to 16 to 20% of the problems. And you can see we haven't got past point 2, and already somewhere between 65 and 70% of the problems we've fixed, which in essence had nothing to do with the mathematics. The third thing is we say, what method could you use to get the answer? And of course, what you're looking for here is 402 divided by 6, but commonly they'll do 402 times 6. If they do that, again, you know that it's not that they can't do division, it's just they didn't know to do division. So again, at this point, we've solved another 10%, so about 75 to 80% of our problems are fixed. It's not till part 4 where we actually focus on the mathematical skills, if you like, which is where, okay, can you sit there and do it? And at this point, you'll find out if they don't know how to divide. And then the last point we ask them is, can you write down your answer? Can you turn the answer you get from doing the mathematics into an answer to the question? Now, why this is important is when a kid puts up their hand, normally as teachers, the first thing we do is go to point 4. We help them with the division part, the mathematical part. When in fact, the problem isn't the mathematics part at all. In fact, for a lot of kids in our classes, the problem is not with their mathematics. The problem is they can't read very well. And the kids who do best in NAPLAN tests, for example, are firstly the kids who can read. So a whole pile of kids are disenfranchised from their NAPLAN test because they just simply can't read the questions well enough. And I know the people who write the test try and make the reading levels really low in the maths one so that everyone can accept it. But there are big issues around reading. So that's where you might use the Newman's error analysis and those series of 5 questions when a student puts out their hand. Now again, I've given you some links there to some examples, and I want you to go away and look at them in your own time. And then there's some things to look at. Look at the language being used. What materials are they being used? What type of subtraction? Those sorts of things. Have a look and see how the teacher works with the Newman error analysis to understand the child's thinking and to then help them solve their problem and to develop in their own understanding and learning. And as you're doing it, of course, always think about yourself as a teacher, because that'll be your job on practicum and when you start your career in the next couple of years. Now, this has been a quick overview of Newman's error analysis, but the videos hopefully give you a chance to see someone actually doing it with children. And I hope when you look at it, you can look at it and say, well, what are some of the positive aspects of it? Why is it useful? How could it help the teacher? But also, like anything, it's an approach that works sometimes, but you don't want to use it all the time. What are some of the negative aspects that were displayed? What things would you like to do differently? Other times when you wouldn't use Newman's error analysis, you'd use something else. What difficulties in learning were the children displaying, and how do you know? And most importantly, once you see that children are having difficulties, what are you going to do as a teacher to remediate these things? Because it's no point just finding out and leaving them there. It tells you something about the teaching and learning that's gone on. And your job is to then go back and remediate it, fix it, help the kids move on. It doesn't matter how good a teacher you are. Sometimes kids will develop misconceptions and ideas that aren't quite what you expected. This is not a problem. The problem is if you just leave it and don't do anything with it. If it's happening across the class, maybe you need to deal with it at a whole class level. If it's just with 1 or 2 students, then you can deal with it as a personal level. But as a teacher, you'll be exhausted at the end of the day and after your mathematics lesson, because you'll teach them something, you'll get them to do something, and then you do your real teaching work, which is racing around and working with the kids, helping them understand something, and importantly, finding out what they've learned, which may be a misconception, and then try and help them to develop it and fix it and learn what is appropriate to learn at that time. We want them to learn the correct conceptions and how they might use it. So here's a problem you could try. The problem is for you to try actually. Again, you can either turn the video off now or you can do it after from the slides. Try and do the problem, and as you do it, see if you can use Newman's error analysis on yourself. If we were doing this in the lecture, I would get you to do it with one another, but obviously online that's not possible. But see how it works. Does it help you? Did you find it useful? Did you find some of it annoying? One of the things that's important as a teacher is you try doing problems yourself. I've often been in classes, even my own, where I've given students a problem, I haven't tried it myself, and all of a sudden I find there's an issue with it. It's too hard, it's irrelevant, it uses content that they haven't learned yet. So I always try and do the problem myself first before I give it to students. So here's one for you to try, and as you do it, use Newman's error analysis, the 5 questions, to see if that helps you solve the problem. So again, here are the 5 questions that I would use. We've said them before, and you'll word them differently. For me, I had it as a poster in the classroom. Okay, so here's some problems that we've seen kids do. This question is 42 subtract 17, and a common answer is 35. And when the student says it, when you subtract, you take the smaller number from the larger. Now, when the student does this, it's not that they are deliberately getting it wrong. They've somehow learned in our classes that this is how you get the answer. All right, so it's not a mistake, it's a conscious misconception. They've learned this misconception from what we've got them to do. All right, and it might be because we've always done subtraction where the 2 digits in the top number are bigger than the 2 digits in the bottom number. So how have they learnt this? How would Newman's error analysis help you see it? What step would you see it at? And then when you did see it, how would you help them learn the correct conception about subtracting 2-digit numbers? Right, the same here for the second one, 300 subtract 136, a common answer. And once you start on class, whether it's practicum or in your career, if you get students at this level, this is the 2 common answers you'll get is 163 and 174. And then there's a reasoning below. So again, at this point, it's not just a matter of putting a red cross next to the student, say you got it wrong. They have tried to work out how to do it, and they've shown you what their thinking is. And your job is to understand their thinking, so then you can help them correct it and build a correct conception. It's a really challenging job as a teacher. but certainly one that is the most important and crucial part of your work. And that's where Newman's error analysis might help. Try some of these things yourself. Have a think, what would I do to help them learn differently? Here's some others. And these are just a few of the common errors you'll see. Certainly not the only ones, but some. A half plus 2/3, a common answer is 3/5. And there's the reasoning given. What would you do about that one? How would you help them understand? 2.06 plus 1.3 plus 0.38, and the common answer is 2.57. Again, why would a student find this answer? Why would this be a common answer? A really common misconception. What have they developed in their head that's enabled them to see that this is the way to get the answer? And how would you correct it? How would you help them see? Right, $5.40 times 0.15, the common answer is $81. And again, how would they have come to this point? How would they think this was a reasonable thing to do? How could you help them see it? This is a critical part of your work. This is students who have sat in your class, done everything you've asked, paid attention, engaged with what's doing, and they've come to this conclusion about multiplying these two things together. So they've learnt it in our class, they've tried, and the question is, how do we help them unlearn this and relearn the correct way? How can we show them? We're just going to show you a couple more. 3 plus something equals 7. Right, the missing add end. Common answer here is 10. 35 adds 67, the common answer is 912. Right, so these are ones we've seen a lot. How did they come to that solution? It's not too hard to see how they might come up with 912. Right, 3 and 6 is 9, 5 and 7 is 12. The question is, what are you going to do as a teacher to help them correct this misconception and develop a correct conception of how to do it, and then move on? I hope we've given you just 3 slides there with different misconceptions that we've seen a lot. So go back and have a think about each one. So when it comes up in your class, you've got some ideas about what to do. So again, I'm just concluding again with a copy of this Newman error analysis, the mistake analysis procedure, and what they're about. Don't just jump straight to step 4 with students when they put their hand up and ask for help, and help them with the maths. Because the most common problem you'll get is the students haven't read the question correctly. Take them through the steps, and then more importantly, get them so they'll go through the steps themselves. So eventually, after a while, when students got stuck, rather than putting their hand up, they would go through and do these steps themselves to see if they could identify it. I think it's really powerful and useful, and I hope it's a tool that you'll find valuable in your teaching career. Here are some other resources that might be of interest to you. Click on them at your leisure. If you find them useful, save the links or download them or keep them. Put it in your file of resources for when you'll start your teaching career. As usual, these slides are in the Learning at Griffith site, and you can get the links from there. So thanks for watching, and I now hope you go and engage with some of these activities. As usual, the videos are linked from the lecture. All right, see you next week.